Okay, welcome to the video for simplifying radical expressions. And we're just going to be focusing on square roots. Most of this applies to other kinds of roots, but we'll talk about that more when those types of problems arise. All right, so let's start off pretty basic here. Let's just look at operations to make sure we know how adding, subtracting, multiplying, and dividing works with radicals. So when you're adding and subtracting, you must have like terms. So here, root 3 and root 3, that means these are like terms. That means I'm just going to add the 2 and the 4 to get 6 and then bring over the square root 3, just like that. Here, they're not like terms. This cannot be simplified, so we're done with this problem. Okay, multiplying. You're going to multiply the parts together. So I would multiply the 2 and the 4 together and get 8. And then I would want to multiply the root 2 and the root 3 together to get root 6. All right, when we're dividing, the same deal goes. So 4 divided by 2 is 2. And then root 6 divided by root 3, well, that is just a root 2 there. So we look at this problem. Well, this becomes a 2, but this still stays square root. Well, I could simplify this 1 over square root 3, or sorry, square root 2. But this can actually be simplified too. In that we can just make this 1 square root of 1/2. So 2 square root 1/2. Just wanted to show you how you can, if you have square root of the top and square root of the bottom, that is square root of the whole thing. Okay, simplifying radicals. So we can take out parts of our radicals. So the first thing we need to do is divide by a perfect square. So divide the radicand by the largest perfect square that goes into the number evenly. So the radicand is in here. And so when I look at root 8, I'm thinking, okay, well, what are my perfect squares? Well, we have 1, but that really doesn't simplify anything. So we have our first 9 perfect squares. So let's make a little list here. If you start here, this can usually get you to simplify most problems. So we have 4, 9 is a perfect square. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 36. 7 times 7, 49. 8 times 8 is 64, and 9 times 9 is 81. So usually this will get most of these done, or at least started. All right, so what number goes in here evenly? Well, 4 goes into there evenly. So I'm going to divide 8 by 4 and break it up into 2 parts here. So I can have the square root of 4 times the square root of 2. Okay, so for those of you like steps, step 2, break into 2 radicals, and then the last step we're going to have here, we'll add some steps as we move on to these other ones, but simplify the perfect square radical. So this 4, I can find the square root of, and it's a whole number, which would be 2. So this would be 2 root 2. This is our simplified radical. All right, what about this one? Well, same deal here. I still have 8, so I'm going to break this apart into 3 times 4 times, well, we can also put our x squared under here because that's a perfect square, times 2. Well, when I go to simplify this, what happens with the 3 out front? These need to be multiplied together. So I would have 3 times, so the square root of 4 is 2, times the square root of x squared is x, all times root 2. And then I multiply all this together, and I get 6x root 2. So last on here, multiply the integers together. Okay, one more here. So I'm looking for a perfect square that goes in here, and we're looking for the largest, right? That's what I set up here. But sometimes maybe we don't know what the largest is, so we just want to break it down. Now, I bet a lot of you know what the largest is here, but let's go ahead and just go by 4 instead. So we know that 4 goes in here. So I'm going to make this the square root of 4 times 100, and then let's also deal with this variable here, but this is the same as x squared times x. So I can take this x squared, that's also a perfect square, and put it over here with the 4. So I have the square root of 4 x squared times, oops, I didn't break this down over here, so 4 times 25 is what I meant to have. There we go, 4 times 25 equals 100. So I'm just disregarding the fact that 100 is a perfect square right now. So I simplify this, and now I have 4x times the square root of 25x. Well, before you know that it's all simplified, you need to double check at the end that there are no more perfect squares that go in there. Or another way to say that, check that the radicand, this is misspelled here. Check that the radicand no longer has a factor that is a perfect square. Okay, so you're checking underneath here at the end, well, are there any more perfect squares that will go in here? Well, there is, right? We know that 25 itself is a perfect square. So for this one, it was pretty obvious, but sometimes you'll get a big number where you don't know what the highest perfect square is, so you're just going to start with 4 and keep going until you have no more perfect square factors in the radicand. All right, so we can pull out a 5. 5 times 4 is 20x times the square root of x. There we go. These are the fully simplified versions of the problem above. All right, one more thing that we want to make sure that you know is rationalizing the denominator. So we don't want radicals in the denominator. So if the denominator is a monomial, multiply by the radical in the denominator. And I'm actually going to change this problem. I'll change it on your notes here. But let's say that this is like this, right? 1 over 2 root 3. So what we want to multiply by is root 3. Right, so multiplying root 3 by root 3 is going to get rid of the radical, but we can't just multiply the denominator by root 3 because that would be changing the value of this number here. So what we need to do is multiply by 1. Well, to create a 1, we're just going to do the square root of 3 over the square root of 3. There we go. So root 3 times 1 is square root 3. And then 2 times root 3 times root 3 would be 2 root 3 squared. Well, if I square the square root of root 3, that's just going to be 3. So now I just have 2 times 3, which is 6. All right, we've gotten rid of the radical in the denominator. And so we've rationalized our denominator. These, if you were to punch them into your calculator, are the exact same value, right? It just looks different. Okay, so what happens if we have a binomial like this? Well, we can still rationalize the denominator. We're going to multiply by the conjugate. Okay, so the conjugate just means that I take the same numbers, but I put the opposite sign in between. So if I have 2 minus square root 3, I'm going to multiply by 2 plus square root 3. And again, we have to multiply the top and the bottom, because if we want to not change the value of the number, we need to multiply by 1. So putting this over itself is the same as multiplying by 1. All right, so the top is going to be easy enough to figure out. 2 plus the square root of 3. And now let's see what happens here on the bottom. I'm going to show you what happens when we multiply it all out, and then I'm going to show you a shortcut to show you that you don't need to multiply it all out every time. So if we multiply, 2 times 2 is 4. 2 times negative 3 is negative 2 root 3. We need more of a line here. Root 3 times 2 is plus 2 root 3. And then root 3 times root 3, and one's positive and one's negative. So it's going to be minus the square root of 3 squared. Okay, so now let's simplify all of that. The top's just going to stay 2 plus square root 3. The bottom, well, these are just opposites here, so they're going to cancel out. So I end up with 4 minus the square root of 3 squared. So the square root of 3 squared is just 3, so I have 4 minus 3. And then lastly, we're just going to end up with 2 plus the square root of 3. So now let me show you how this could actually go a little quicker as far as multiplying the denominator together. This is known as a difference of squares. So this is a difference of squares already factored, and this comes up a lot. But if we have a squared minus b squared, then that's the same as a plus b times a minus b, right? So this is a difference of squares. We have 2 squared terms and subtraction in the middle, and this is it factored. Well, this is just a difference of squares already factored. So the 2 are the a terms. So you can see here, I just need to bring a 2 and square it. And then the b term is root 3, so I just need to put a root 3. and square it. And then I need to put a minus in between, or negative in between, right? And then that would just simplify to that. So rather than multiplying it all out, if you can notice that it's difference of squares factored, you can just square the first, square the last, and put the negative in between. All right, let's try this fun one over here. So we're going to multiply the top and the bottom. Actually, you should pause the video and give this a try and see if you can figure it out, because it's pretty much putting together all the things I just taught you in this video into one problem here. All right, so we're going to multiply the top and the bottom. I'm just going to write right over my equal sign here, by 4 plus root 2. 4 plus root 2. All right, let's start with the bottom, because now that we know that little trick, it makes it a little faster and easier. I'm going to take 4 and square it, and that gives me 16. I'm going to take root 2 and square it, and that gives me 2. And then I'm going to put negative in the middle, and then I'll come back and simplify that on the next step. And then this one I'm actually going to have to multiply out, because it's not a difference of squares. We don't have matching terms here. All right, so 4 times the square root of 8 times, well, root 8 times root 2 is going to give us root 16. And then 3 times 4 is 12. And then 3 times root 2 is 3 root 2. All right, so multiplying together radicals, just like I showed you above. All right, so what can I simplify here? Well, on the bottom, I can take 16 and subtract 2, and I'll get 14. And on the top here, well, this can be simplified. I can pull out, there's a root 4 in here, root 4 times root 2. If you need to see that visually, I'm breaking this part into 4 times root 4 times root 2, which means I can take the square root of 4, multiply it times 8, and I end up with, multiply it times 4, and I end up with 8 root 2. Then the square root of 16, well, I can find out what that is. That's 4 plus 12 plus 3 root 2. Well, before these were not like terms, but it turns out that they are, so we can go ahead and add those up. So I would do 8 plus 3 is 11 root 2. And then 4 plus 12 is 16 all over 14. And then some of you might be tempted to simplify this, and it's going to come up all year, but you cannot simplify if you have a binomial or a trinomial, you just have some terms added up on the top. You can only divide by the term on the bottom if it goes into all the terms, right? So we have 2 here. There's nothing that I can simplify with 14 and 11. Therefore, I'm not going to simplify the 16 and 14. I could separate them up if I wanted to. I could go like this, but it's not necessary. But just so you see what's actually going on here. And then I would have 16 over 14, which would be the same as 8 over 7. Right? If I was dying to simplify this, I could do that, but that's not necessary. I just want you to clearly see that that 14 has to go into both parts. Okay, that's it. Thanks for watching.